What's going on, Algebra Bros? It's Mr. C here, and in this video I'm going to show you how to solve problem 2 of the Module 6 written work. Here you're seeing the graph of y1, which is equal to the absolute value of 4x minus 3. I've got that graph in dark blue and also labeled as y1. We also have the graph of y2, which equals the constant value of 7, which is this horizontal line here, and of course I've marked that as y2. The viewing window, or the window settings I'm using, correspond to the standard viewing window. So again, on the x-axis, that's from negative 10 to positive 10, and on the y-axis, negative 10 to positive 10 as well. And I didn't mention this in my last video, but I will here. The XSCL stands for the X scaling. Of course, there are more tick marks that would be on both axes, and there'd just be a 1 unit gap between each tick mark. All right. So once you enter y1 and y2 into the y equals menu, if you want to hit zoom 6, that automatically generates these window settings and also these graphs. And essentially that takes care of part A, which brings us to the real meat of the problem, part B, where we want to now use the graphing calculator to solve the inequality y1 is greater than y2. Of course, we'll put our answer in interval notation. Alright, so in my last video you saw that one of the key things to doing this is to find the point of intersection. And of course, you're seeing 2 points of intersection, and we'll want to consider both of those in order to help us solve this inequality. So again, using the intersect feature to figure out this point here, you'd use the intersect feature, and that would have the following coordinates to 2 decimal places. -1, comma 7. I think those come out to be nice whole integers. So there we go. That's the location of that point of intersection. Then the second point of intersection right there, which is in quadrant 1, to 2 decimal places. This is 2.5, comma 7. And I think this just comes out to be exactly 2.5. If you want to put 2.50, not a big deal. But anyway, going to the inequality now, let's look at how to interpret it using these graphs. When we want to solve the inequality, y1 is greater than y2, reading this from left to right, that's how you would say it, y1 is greater than y2. The greater than symbol in the graphing situation tells us to find the parts of the graph of y1 that are above any parts of y2. So in the last video, this inequality was switched, and it was a less than symbol, and we were interested in the pieces that were under. So if less than corresponds to under, then greater than would actually correspond to above. So to do this, let's go back up to the graph, and I'd like to look at the first point of intersection going from left to right. So that point of intersection is at -1, comma 7. And what I'm going to do is actually go down to the x-axis and label a tick mark of -1. As you saw in the last video, that was something we did, and it turned out that this tick mark value was involved in our interval notation. And while we're at it, why don't we go ahead and put a tick mark right underneath the second point of intersection and mark that as 2.5. Okay, so now let's go back to the point -1, comma 7. And looking to the left of it, we want to figure out, okay, which graph is above which one. Clearly you're seeing that the dark blue graph is above the green graph, all right? And noting that the dark blue graph corresponds to y1, this is definitely a piece that is going to be helpful for our answer. This is actually a part of the graph of y1 that is above the graph of y2. In inequality notation, that would just be y1 is greater than y2. All right, if you look to the right of this point of intersection, the roles interchange. Now we have the green graph being above the blue graph, and that actually, that trend continues until we meet up at our second point of intersection at 2.5, comma 7. All right, all the way between these 2 points of intersection, we have the graph of y2 above the graph of y1. But look at what's happening to the right of the second point of intersection. Now the graph of y1 is above the graph of y2. So this is another piece of the graph of y1 that we're interested in, because this piece of the graph of y1 is above the graph of y2. In inequality notation, we'd write that as y1 is greater than y2. Alright, so we're on to the last phase of this. Now that we've identified the parts of the graph of y1 that lead us to our solution, it's now time to go ahead and figure out just exactly what our solution is. As mentioned in the last video, you want to look at the corresponding parts of the x-axis. And what I mean by that is we want to know which part of the x-axis corresponds to this piece of the graph of y1. And the part of the x-axis that corresponds to this piece would be from negative infinity all the way up to negative 1. So what I'm going to do is put negative infinity there and then shade from negative infinity all the way up until I get to negative 1. So now what I'd like to do is decide on whether we should use a parenthesis or a bracket on this negative 1. And if you look at the inequality symbol, there's no bar underneath it. Therefore, we wouldn't want to use a bracket, but instead we'd want to use a parenthesis. All right, so I'm going to draw a parenthesis facing towards the direction of shading. And in a similar vein, we would want to shade to the right of 2.5 all the way down to positive infinity, because it's exactly this part of the x-axis that corresponds to a second piece of the graph of y1 that is above the graph of y2. All right, and again, for similar reasons as using a parenthesis on negative 1, we'll use a parenthesis on 2.5. Of course, we'll have it pointing in the direction of shading. All right. So we're just about done. All we need to do is whip up the interval notation for both these pieces of the x-axis here. And we'll go from left to right. Again, by default, use parentheses on any infinities, whether they're negative or positive. All right, so the first shading goes from negative infinity all the way up to negative 1. So comma negative 1, parenthesis on that. The second shading starts just to the right of 2.5, so parenthesis 2.5. comma, and all the way down to positive infinity. And so that we can keep both of these as part of our single solid answer, you probably know what to do. We'll use a union symbol to tell the reader that we want to consider both of these parts as our solution. Alright, and that's how we take care of this problem using the graphing calculator. Of course, again, a critical piece of this was to use the intersect feature to find those points of intersection, and then another key piece is to interpret the inequality symbol properly. So I hope that by watching both the videos for the written work for Module 6, you have a better understanding of how to solve an inequality using your graphing calculator. Let me know if you have any questions. Otherwise, thanks for watching, and I'll see you next time. Thank you.